Hello, I'm Leila Carvalho, Climate Science Professor in the Department of Geography, UC Santa Barbara. Today, I'm going to talk about sundowners, fire weather in Santa Barbara, and the Sundowner Winds Experiment SWEX. To have lived in Santa Barbara for more than 2 years, you probably have seen a significant wildfire somewhere in the slopes of the San Ynez Mountains. Yes, Santa Barbara is a fire-prone region. What these wildfires have in common? Well, they have all been enhanced by strong winds in the southern slopes of the San Ynez Mountains, known as sundowner winds or sundowners. Sundowner winds are gusty winds blowing from the southern slopes of the San Ynez Mountains towards the coast. Typically, they peak from late afternoon to early morning. They cause relatively warm evenings and significant drop in humidity. They are considered the most important fire weather conditions in Santa Barbara. They occur year-round, but are more frequent during spring, from March through May. To give an example of how complex these winds are, I'm showing a model simulation of winds at 6 p.m. during the Resuscita fire in 2009. Arrows indicate wind direction, and the magnitude of the winds is shown by the size of the arrow. Colors indicate relative humidity, with red colors showing drier conditions. Notice how much winds vary in direction and intensity across the southern mountain slopes. They usually exhibit a northwest direction in the west and northeast direction in the eastern slopes of the San Ynez Mountains. Note also the dramatic variability in relative humidity. Usually, drier conditions are observed in the eastern portion of the domain, where more people live. Thus, it is important to properly predict wind intensity and direction over time and where these winds are going to be stronger, particularly if we have a wildfire. The Sundowner Winds Experiment is a collaborative project supported by the National Science Foundation to investigate sundowner winds. It results from a collaboration of 9 institutions from all over the country, including the UC Santa Barbara, the National Center for Atmospheric Research, Naval Postgraduate School, San Jose State University, University of Virginia, SUNY Albany, University of Notre Dame, Jackson State University, University of Colorado, Boulder. It counts with a strong logistic support of the National Weather Service and the Santa Barbara County Fire Department and U.S. Forest Service. The SWEX experiment will extend from April 1st to May 15, 2022. Goals of these projects are to integrate multiple sophisticated instrumental platforms to 1. Better understand mechanisms driving the spatial and temporal variability of sundowners, improve model forecasts of sundowner winds and extreme fire weather conditions, strong winds and low humidity, transfer our scientific results to the National Weather Service and the Santa Barbara and Montecito Fire Departments, contributing to a more accurate forecast of conditions leading to extreme and fast wildfire spread risks. Finally, educate the local community about wildfire risks in the Santa Barbara County. During 45 days of the experiment, we will have 19 stations placed in several locations in the San Ynez Mountains and San Rafael Mountains, the red symbols, plus 6 lidars and 3 wind profilers that use remote sensing to quantify profiles of wind speed, direction, and turbulence. These instruments are placed in public land and private property. Some of these properties belong to the Santa Barbara County Fire Department. They are placed in key locations in the coast and in the San Ynez Valley, Sedgwick Reserve, San Ynez Airport, and Rancho Alegre. We also have mobile platforms such as the Naval Postgraduate School Twin Otter, equipped with sophisticated lidars that are capable to evaluate profiles of temperature, humidity, winds, and aerosols. They will help us to understand what happens with these profiles across the mountains, along the valley, and the Santa Barbara Channel. We also have the Jackson State University Meteorological Unit mounted on a car that can measure near ground temperature and humidity. The University of Virginia mobile LiDAR is utilized to evaluate profiles of winds as the car drives along the roads. We also launch weather balloons from 4 sites, coast and valley, with zones that go above 32,000 feet, measuring profiles of temperature, humidity, and winds. Here's an example showing how we integrate airplane, mobile measurements, and radio sounds in the red dots. So we can see as the airplane flies, cars will move, radio sounds will launch balloons, and then we integrate all this information. Cool, huh? To finish, I'm providing one quick result showing what the mobile LiDAR observed and was traveling along the 101 during a sundowner event. What you see on the left panel is a profile of wind speed, and on the right panel, a profile of wind direction. When the car was passing across West Goleta, it registered less than 5 miles per hour wind with southeast direction below 1,000 meters at 6 PDT. As the car moves west and passes across Arroyo Rondo, 1 hour later, winds increase to 50 miles per hour at elevations less than 100 meters. This is how dramatically winds can change in space during sundowner events. This also illustrates how important it is to have a good forecast of these winds. Measurements are necessary to validate these forecasts. We'll have much more to share in the future, so thank you for your attention.